Last week, I talked about how J.J. Thomson and Millikan discovered electrons through their cathode ray and oil drop experiments. If you haven't seen that video yet, I would highly suggest watching that before moving on to the rest of this video. It will be linked in the description box below. Today, in part 2 of the structure of the atom, we're going to be talking about the discovery of protons, neutrons, and the modern view of the atom. Ernest Rutherford conducted the gold foil experiment. In his experiment, he used a device that emitted alpha particles to send out a stream of the positively charged particles into thin foils of gold. Rutherford intended on seeing how the alpha particles would react to the gold on an atomic level, so he could figure out more about the structure of the atom. When he conducted this experiment, however, he found that some of the particles deflected off course or even bounced back from the foil. It was already known that some sort of positive charge existed within atoms, if you remember the plum pudding model from the last video. But Rutherford also knew that the charge was so small that the positively charged alpha particles shouldn't have felt such a great repulsion and deflected greatly off course. Most of the alpha particles deflected very little, as expected, which meant that the atom had some sort of positive charge, since like charges repel. But sometimes the particles deflected a lot, and he hypothesized that this was because there was a very small but very dense core called a nucleus with positively charged particles called protons. When the alpha particles got close to or hit this nucleus, they felt a greater repulsion to the charge and deflected greatly or even bounced back. So now the model of the atom consisted of rings of electrons with a positively charged nucleus in the middle. But one problem remained in the model. The masses of the elements didn't make sense. Hydrogen, the simplest atom, consists of 1 proton, and helium consists of 2. Atomic mass is essentially just based on the number of particles in the nucleus, since electrons are so light that they can be ignored. Using this logic, since helium has double the amount of protons as hydrogen, the ratio of the mass of helium to hydrogen should be 2:1. But that's not the case. Instead, the mass of helium is 4 times greater than the mass of hydrogen. This is when Rutherford and other scientists realized that there must be a third, neutral particle in the nucleus that contributes to the mass but doesn't affect the charge of the atom. James Chadwick proved this by conducting a similar experiment to Rutherford, except with beryllium instead of gold, and found that radiation similar to gamma rays, a neutrally charged particle, was emitted from the metal. He named this new neutral particle neutrons. So now we have a general view of atoms that you may have seen before, a nucleus made of protons and neutrons with shells of electrons around it. But that's still not exactly how we view the atom today. I need another visual aid to explain this one, so I'll be right back. Arjun, what are you doing with my avocado?
I'm making guacamole.
What is up with everyone eating my prosperity demonstrations? I'm using this.
Wait, but I need that.
As I was saying, avocados show a distribution of protons, neutrons, and electrons. Atoms are not just a nucleus with rings of electrons around it creating a perfectly circular atom. Instead, they're more like misshapen clouds. The protons and neutrons tend to stick together in the middle, where the pit is, and that's what we call the nucleus. The electrons then surround this in varying concentrations and shapes. One thing that's not accurate about this model, though, is the scaling of the nucleus. In reality, the nucleus is about 1/100,000 of the entire atom. Overall, though, this is a good way to show that atoms are a positively charged nucleus with clouds of negative charge around it. Please like, share, comment, and subscribe for more videos every week.